Hello. Hey guys, how you doing?
Hi, Peter.
Hey,
Happy New
Peter.
Year.
Good evening.
Good. Awesome. Thanks for taking the time. I know it's a little bit probably late where you are, guys, compared to where I am. It's only 10 in the morning here, but thanks for taking the time. Today's episode, it's episode 69, and we'll be talking about implementing mutual TLS in Istio multi-cluster environments using SPIFFE and Spire. So I know you guys did this at KubeCon, and I've looked at the talk, and it's a lot about mutual TLS, how it works, how does Istio dole out the certificates, how the Spire and SPIFFE are integrated with Istio. And I'm very curious to see how everything connects with Spire and specifically doing the federated thing across multiple clusters. So before we start, why don't you guys introduce yourself first?
Sure, I can start. Thanks for the invitation, Peter. It's a pleasure to be here. So, yeah, I work at Solo. I'm in the group platform team where we are building a multi-cluster service mesh on top of Istio and Envoy. So, I'm pretty familiar with the topic we will be talking today.
Yeah, and I am Edu. I am customer success engineer. I live also in Madrid, near from where Samuel lives. And yeah, I work helping our customers. Engineer. I live also in Madrid, near from where Samuel lives. And yeah, I work helping our customers.
I think we lost your audio, right?
Yeah, we are losing you, Edu. You have some sound issues.
I think we lost your audio, right? Yeah.
You have some sound issues.
Yeah, it looks like it's bleeding through. But anyway, yeah, it's still bleeding through. Yeah. I don't know if you have like a YouTube playing or something, and because I can hear myself. Maybe try putting yourself on the headset or something if you can. And let's see. Uh, while we're waiting, I know we have a lot of people watching. Say hi in the comments. I always say that, but then no one says hi. So if you say hi, I might send
While we're
you
waiting,
like
I know we have a
sticker
lot of people watching.
stickers or something. Uh, first person who says hi, I'll send you some stickers. I promise. I just don't know what stickers and when. Samu, how was your KubeCon? How
It
did you like
was very interesting because my background is more technical and it was my first time in the KubeCon. So I went to very interesting talks and very interesting hot topics that are right now in the yeah, I mean everyone is talking about. So for example, backstage or ambient Cilium. So it was a really interesting KubeCon. And I could also talk with so many of our customers because sometimes in the engineering side, it's hard to interact with them and getting their feedback, understanding how they are using our products, how they are using Istio. So yeah, it was kind of cool.
nice, nice. Edu, how about you? Did we get the thing resolved? Let's see if you can unmute yourself.
Yeah, yeah.
Perfect. Okay. No, is it?
Resolve. Let's see if we can. I don't know.
No. I can still hear myself. Yeah, no, it doesn't. It doesn't work. I have to say, we did try this before. Uh,
Yeah,
yeah,
maybe the Yonin will fix it.
yeah. He'll fix it, but I don't know. Well, let's asking the audience. I know a couple of people said hi. It looks like the sticker promise helped. Now I'll have to do good on that. But people like anyone watching, how was your like? Did anyone is anyone using Istio? That's the first thing that I'm gonna ask. And then if you're using Istio, have you used Spire before? Maybe if you can just say in the comments yes, no, or Istio or Spire SPIFFE. Edu is back.
Do you hear me now?
Yes, perfect.
Okay. Sorry.
All right. Well, it's
Sorry.
we'll say it's the distance. It's the distance, right, between Seattle and Spain, and that's why we we had these. But all right, that's fine. Well, let's get started. I'll do this, and then Edu, take it away.
Well, I think I will start first, and
Oh,
then
you will
Edu
start
will
first.
go after.
Okay. All
So
right.
I will start first with mTLS. So the idea here is because the talk is about how to enable mTLS with Spire and SPIFFE in Istio multicluster. I'm gonna talk first about what is mTLS, what is SPIFFE, what is Spire, and Edu will talk about, after me about what is Istio, how to enable Istio in multicluster environments, and how to integrate everything in a very cool demo that you will see at the end of the presentation. So the first thing is basically what is mTLS. Okay, so you are probably, most of you are familiar with traditional TLS because most of our websites are using it. TLS is a way of encrypting traffic between a client and a server. A server can be any website. So in this case, the client has to validate the server certificate in order to be able to access the content in the website. With mTLS, this is more robust because here the client and the server authenticate each other. So now the server also authenticates the client. So the client has to present a certificate to the server with the client ID. Okay, so in this way, the server can validate the client and restrict the access to only specific clients. So this is more powerful, and is very powerful in Kubernetes environments, for example, when you want to restrict your apps to only be accessed by some specific clients. So what do we need in order to implement mTLS? It is quite easy. If we only have a client and a server, we have to generate a certificate and a private key for the client and the server. So with our certificate authority, we just request a client a certificate and a key for both of them, and that's all. And we can establish our mTLS communication. Okay, but in enterprise environments like Kubernetes environments that you are probably more familiar with, this is more complex because you have a lot of apps. Many of them are talking to each other. You want to restrict the traffic to only some of them or a specific subset. So I'm dealing with all this complexity and generating certificates for all of these applications. And even if you want to rotate them more frequently, just short-lived certificates, for example, you cannot do it manually. It's a nightmare. So this is the problem that the SPIFFE and SPIRE creators try to solve. And it's solved in a very smart and intelligent way, and it works pretty well, as I will explain you now. So, okay, SPIFFE. SPIFFE is just the standard for Spire, okay? SPIFFE is an open source standard for securely identifying software systems in dynamic environments, in cloud environments, and Kubernetes environments are a very good example of these kind of environments. And it defines just few concepts that the Spire implementation will have to implement or will have to implement in order to satisfy the SPIFFE specification. And the first one is the workload API. The workload API is the core of SPIFFE, and it's where everything happens. Okay, the workload API is in charge of generating the SVIDs. The SVIDs are the SPIFFE verifiable identity documents. They are cryptographic documents, or it's a document where we can put the workload identity inside. Okay, and with that identity, it's the workload will use this SVID, this document, to just identify themselves to the rest of the workloads in the trust domain. And we have the trust domain. The trust domain is basically all the workloads that are managed by the workload API.
Mm-hmm. So basically, SVID is, if you go to SVID is just a X509 certificate.
Yeah, I will talk about this in slides, but it was just the high-level design, but correct. I mean, the SVID, there are two different, the X509 certificate and the Joe token. But just one thing before is that the SPIFFE is how we identify our workloads. Okay, so we put the SPIFFE ID inside these SBITs, okay, inside the SPID certificates, and the workload API will be configured to set the SPIFFE ID for us, because SPIFFE only has to be URI compliant, but it's a custom. It's defined based on the customer or the client or the user environment. Okay, basically we put our trust domain slash some kind of workload identification for that specific workload. Okay, and as Peter was mentioning, an SBID can be two different types. Okay, it can be an X509 certificate that probably you are familiar with, and the JOT token. The X509 is recommended over JOT token because it's more secure, and the rest of the talk, when we are talking about SBIDs, we will be talking about always with this implementation and this integration, it will always be an X509 certificate. And it looks like, as you can see here on this slide, is basically a certificate. Okay, it will be signed by the Workload API certificate authority. And the only difference is in the subject alternative name. In that extensions, we are putting the SPIFFE ID inside that in the subject alternative name. Okay, so the Workload API will return the SBID and the private key to the workloads, and the workloads will use these informations to be validated by the rest of the workloads in the trust domain. And one last cool feature that SPIFFE defines is the federation. And this is very useful for multi-cluster environments because in our case, for example, we will have different trust domain. Every cluster will be a different trust domain. So when we have a different trust domain, we need a way of identifying or validating workloads from other trust domains. So in our workload API, we have to expose our public information, the public keys that we are using to generate the certificates in an endpoint. It's known as the trust bundle endpoint. And this trust bundle endpoint will be used by the other trust domain to be able to validate the certificates from the different trust domain. Okay, so these are all the concepts in SPIFFE, and let's review a specific implementation of SPIFFE, which is SPIRE. Okay, there are other implementations, but the most famous one and the most adopted one is SPIRE, and we will also see a specific deployment of SPIRE in Kubernetes. Okay, it's kind of interesting. It's using very modern concepts, and I think you can learn so many things of the SPIRE deployment in Kubernetes. So in SPIRE, now we have real components. Okay, this is not just the definition, this is the implementation. So now the workload API is going to be implemented by an agent. Then we have a server where the different workload entries are registered, and we have other components. So and different process, okay, in order to make this work. So in the server, the first thing we have is the registration API. The registration API is used to register the workloads into the SPIRE database. Different database backends are supported by SPIRE server with the data store plugins that you can see here, okay, in the DB. So you can use SQLite, for example, or Postgres. So many different options are supported. And the same with the certificate authority, okay? We have the upstream authority plugins, so you can decide what certificate authority you are gonna use, because as we are generating certificates, we need a certificate authority, okay? You can use by default self-generated one, but you can also select that, okay, I'm gonna use an intermediate authority that generated by a root CA. Okay, this is more enterprise and more popular. So there are different configurations that we can do for the server. And then we have to authenticate the agents against the server in order to get the different SBIDs for the workloads in the domain. This is done through a process known as node attestation that we will review deeper now in a second. And for the workloads, in order to get the SBIDs from the agent, we have the workload attestation process. Okay, so the first thing, the registration API in Kubernetes. Okay, let's review this, how it works in Kubernetes environments. So in Kubernetes, the Spire server, we have two different containers in the Spire server pod. We have the Spire server itself, of course, and the controller manager. The controller manager is continuously watching for the pods in your environment, and you configure the controller manager by the cluster SPIFFE custom resource. With the cluster SPIFFE custom resource, you can select, okay, only some pods, for example, with this pod selector that match these labels. For example, the Spire managed identity equals to true, will be registered into the Spire database. And the SPIFFE will be retrieved or will be generated according to this SPIFFE ID template that we have in here. So in this case, we are putting the trust domain, then /ns for the namespace. So we are registering the different pods by the namespace and the service account that is being used by these pods or by the workload pod. So once all our workloads are registered into our Spire server database, the agents will request, are continuously requesting these SBIDs from the server. So actually, the SBIDs are in the agents, okay? So the agents are caching these SBIDs, and when a workload needs an SBID, it will request it to the agent, okay? The workload doesn't interact at all with the Spire server. So, but in order to get all these SBIDs from the server, the Spire agents needs to be authenticated and verified by the Spire server, because it cannot be impersonated, or it shouldn't be impersonated. So only the Spire agents in our trust domain and only the Spire agents that we trust are entitled to get the SBIDs from the server. So in order to do this, this is known as node attestation. So in order to do node attestation, the Spire agent will will generate a CSR, a certificate signing request, and the service account token mounted into the Spire agent pod will be sent to the Spire server. Okay, so this first communication has to be done with TLS. Okay, not mTLS yet, just only TLS, because we are sending sensitive information. So this service account token needs to be through an encrypted channel. The Spire agent will get this information, and it will get the agent pod metadata from the Kubernetes API using the token review API, because with the token, using the token review API with a service account token, you can get a lot of information for a service account and all the pod information. And with all this information, the server will register the agent into the Spire server database, but with a different format. This is not the format that the workloads will be using. In this case, we are using, as you can see here, the SPIFFE ID is a bit different. We also have the trust domain, but then we have the Spire/agent/Kates PS80. This means the plugin we are using to register the Spire agents. In this case, it's the projected service account token. Okay, so that's why it stands for this weird name. Okay, it's the name of the plugin that we are using to register the agents. And then we have the selectors. The selector are the different agent information that we are using to register into the database. So finally, with this information, the Spire server will return an SBID for the agent, and the agent will use this SBID to establish an mTLS communication with the Spire server. Now it is mTLS, and to retrieve and cache all the SBIDs for the workloads running in that node, okay? Because the Spire agent is running as a daemon set in Kubernetes environment, so all the workloads in one node just identify or gets the SBIDs from the Spire agents running on that specific node. And the final step is workload attestation. Okay, now we have all the SBIDs in the agent, and now we want the workloads to retrieve SBIDs for them. So this is done, as I said, the Spire agent is running as a daemon set on the node. So thanks to the CSI driver, the Spire CSI driver, what we are doing is we are mounting a Unix socket into that node. And the communication between the workload and the Spire agent will happen in this Spire socket. So at a node level, or a Unix socket level. So the workload will request, we have in this Spire, in this unit socket, there is a gRPC API running in and exposed by the Spire agent. So the workload will request that gRPC API on the Unix socket and will try to request the SBID. So the Spire agent will get that request and will get the workload PID for that specific request. This is important because the PID cannot be impersonated by the workload because the workload doesn't choose what PID is assigned to. So this is very important because this is where we are relying on all the identity is relying, in this case, in the Kubernetes environments, is using the PID of the workload. And with that PID, we can get the pod information because with the PID, we can go to the kernel C groups, and from the kernel C groups, we can get the container ID and the pod UID. And now with the pod UID, we can get we can correlate information because with the kubelet API, we can retrieve all the pods or all the information from the pods running in that node, and we can correlate pods. So with the pod UID, we can get all the different labels and the rest of the information from that specific pod for the workload pod, and then we can register or we can get the selectors, and with the selectors, we can retrieve or the agent can select the specific SBID, matching these selectors from the pod information to just get the specific SBID for that workload, and the agent will return the SBID to the workload, and then the workload can use this SBID to establish an mTLS communication, as you will see now with Istio and SPIRE.
So what basically? Can you go back a slide? I just want to confirm something. So the Spire agent will get the workload ID, right? The process ID, and then use that to collect other extra information, and then it will compare that, I think, to the registration entries that were created by the server, right? And the ones that were sent back to the agent. And then if they are the same, it's gonna know which SPIFFE ID to issue, right, to the workload, right?
Yes, correct. Basically, that's exactly. With the PID, you get the pod UID, and with the pod UID, you get the pod metadata. And with the pod metadata, you can, because we have a very similar entry here, but for the workload with selectors. And basically, it's okay. The pod matching this selector is the pod that I will give you the SBID for. So yes, that's the.
Oh, so it's basically the server watch the controller manager or something like that, right? What controller man? Yeah, it's gonna watch all the pods, right? And then it's gonna create registration entries for all of them based on this template, right? Well, for the ones that match the labels, right? Let's say that, right? It's gonna create the registration entries, and then independently from that, the agent is gonna do attestation of the workload to get those selectors as well, and then it's going to compare it. Hey, do I have anything, like, is there anything matching this in the registration entries? And if it is, here's the SPIFFE ID for it, right? Here's the identity for it, right?
Yeah, that's correct. Exactly. That's how it works.
Yeah. So there's a question from GK. How does Spire agent know the workload process ID is Spire? Does Spire agent have higher privileges?
Yeah, it has to read information from the host, so it's running as a privileged pod that it's able to get the PIDs from the host where it is running.
Yeah. Correct. All right. Do we switch to Edu?
Yes,
right?
Edu's time. Yeah.
There you go.
Yeah, so hope I don't have problems with audio now. But yeah, thanks Samuel for explaining it. Now I'm going to explain Spire and Istio in action. So I'm going to go through how does Istio and Spire communicate between them, how do they integrate between them, and finally I'm going to do a demo of how it's done in a real scenario. So first of all, I'm going to make like a high overall architecture overview of our setup of our demo, which consists basically on two Kubernetes clusters, Istio Cluster 1 and Istio Cluster 2. In each of them, we have deployed one Spire server, which will generate the bundle of each cluster and will connect between each other using Spire Federation. So basically, we will have one Spire agent per cluster because we have one Spire agent per node, but in this demo, we have only one node per cluster. So the Spire server will connect with the Spire agent on the same node, and the Spire servers will communicate between them in order to make this federation and to trust the bundles from each other. Also, in order for the applications to be aware of how to reach applications in other clusters, to be aware of the DNS of other applications, and to be able to communicate securely, we have deployed Istio in multi-cluster environment running in the same network. This can be done in multiple ways, running in multiple networks, in the same networks. In this case, I have done everything in the same network just for demo purposes. So in this cluster, we have the Istio control plane, and we have deployed some applications. So the users will go through our Istio Ingress Gateway, then they will reach our front-end product page, and requests will go to our backend applications. So if we see here the flow, users reach Ingress Gateway, front-end, and then they reach the backend applications, making requests also to cluster number 2. The only application that we have deployed 2 times is details, just to show these high availability capabilities of Istio. If any of those applications will fall down, Istio will know how to route the traffic, 100% of the traffic, to the cluster in which this application is healthy. So basically, this is our architecture for this demo. And just for observability purposes, we have deployed one Prometheus on each cluster, which will federate metrics into Thanos in order to show traffic from Kiali.
So the way that multi-cluster Istio is set up with like multi-cluster setup in regards with networks doesn't really matter for SPIFFE Spire, right? It doesn't matter how the setup is, right?
Yeah, it doesn't matter at all. That's why we choose to have everything the same network, just to make the simplest Istio installation. Because we didn't want to complicate things. The only thing that would change in case that we have multiple networks, we would have to add an Istio East-West gateway doing the pass-through, but anything would change for the integration between Istio and Spire. Yeah. So yeah, this will be our architecture for this setup for the demo. So first of all, I'm going to explain how does Istio multi-cluster work. So in this case, as I said, we are running only one single network. So in order for one service running in Kubernetes cluster 1 to know how to call this service running in Kubernetes cluster 2, we need to be able to call the API server from the remote cluster. So for that, we use this command, istio create remote secret, which basically gets the kubeconfig of the remote cluster and applies it to the current cluster. This way, Istio will know the kubeconfig and will know how to execute calls to the API server of cluster 2. So we are able to execute calls directly from service A to service B. This is the configuration that we have for Istio multi-cluster. Basically, we have to specify the Istio cluster name, the mesh ID, which will be the same for both clusters, and same for the network ID. Also, one modification that we had to do to Istio upstream was to include this field, trust domain aliases, which basically says to an Istio workload to also trust requests coming from this trust domain, Istio cluster 2. So this is the Istio multi-cluster setup, and now it comes how does Spire federation work. So as I said before, we have one Spire server in each cluster, and in order to deploy it, we need to enable federation. In Spire, we deployed it using Helm, and as Sam explained before, we need to specify the SPIFFE ID template. So in this case, we choose to do it with trust domain, namespace, and pod service account name, which is the default one. We also have to include which domain we will federate against. So Spire Server 1 will federate against Spire Server 2. And we need to include the URL of the service of the remote cluster in order for Spire Server to go to the service, fetch the bundle, and trust this bundle in both clusters. So in both clusters, we will trust both bundles from every cluster.
So basically, the Spire server, the values file is used, the same one is used in both Spire servers. The difference being that one federates with cluster 1 and the other one federates with cluster 2?
Yeah, that's right.
Oh, okay. So, and this is just needed to basically say, hey, these two Spire servers can talk to each other, and they're the same thing, right? I mean, not the same thing, but trust stuff issued from this one in that one, and vice versa, right?
Yeah, that's right. And we also need to specify to change the service URL in order
to the other one. Yeah.
In order to go and fetch the bundle. Yeah. So yeah, now we have Istio Multicluster, SPIRE Federation, and now let's go to explain how do they integrate together. So before doing that, I wanted to explain how does Istio do it by itself. And basically, Istio workload is composed by two containers, the application container itself and the Istio proxy container, which consists on two components. One is the Istio agent and one is Envoy. What Istio agent does is bootstrapping the proxy and provision identities to the workloads. And basically, when the Istio agent is running, it makes a certificate signing request to IstioD. If we already don't have any certificate, IstioD signs the certificate, and Envoy is able to communicate with the Istio agent thanks to SDS, which is the Secret Discovery Service, which is a Unix domain socket, which is mounted on the Kubernetes node. Envoy knows how to talk to the SDS API. So thanks to this approach, Envoy is able to get the certificate and the key needed in order to communicate with other workloads. So this is how Istio Upstream does it. So let's go of how this changes if we implement Spire now. So basically, if we implement Spire, IstioD agent no longer communicates with IstioD in order to make that certificate signing request, but thanks to the CSI that Spire mounts into the node, we are able to mount this CSI from Spire into a known location of the workload socket. So basically, what we do is communication directly between the Spire agent and Envoy using SDS. So in a socket inside the same Kubernetes node. So basically, we are mounting the CSI of Spire into this known location, so they communicate directly between each other in a socket.
So the Envoy would knows how to like talk SDS anyway, right? It's just the implementation. In one case is STOD, in other, like in this scenario, is Spire agent, right?
Yeah, that's right. So in the previous case, we need to communicate with STOD first. For Envoy, nothing changes. Things changes just for STOD and how we communicate with each other. Yeah, that's it. So once we have that, once we provision the Istio workloads and we make this integration, as Sam explained before, we have this Spire controller manager, which basically is watching our workloads that are running in our pod. So if we need to provision identities to any workloads, the Istio controller manager will know. It will trigger reconciliation. So in this case, it means that there is one pod which is named product page v1 that is running into our node, and we need to create an entry for it. So the controller manager knows it. It creates an entry on our Spire server, and we can list this entry on the Spire server pod. Basically, what this entry has is the entry ID, the SPIFFE ID with the same template that we generated before with domain, namespace, and service account, the parent ID, which is basically the Spire agent on the same node, the SVIDs, and the selector, as Sam explained before. We have the pod UID, which is the same as in the Kubernetes YAML of the pod, and the domain that we federate with. Selectors can be modified also. We can add more selectors. This is the default installation. So basically now we have our entry of our workload in our Spire server. And if we check the Envoy configuration itself, we are able to see that now both subject names are matched. So if we check the SANs, we have the one from domain 1 and we have the one from domain 2 for the same workload. You can see domain, namespace, and service account.
And that one was the setting that controlled that was the not bundles with, what was it called? It was in the Istio operator, right?
Yeah, trust domain aliases, right?
Trust domain aliases. Yeah. Oh, okay, so that one basically tells tells STOD when it's generating the configuration to also use to create another entry with this other alias as well, not just with the original one, right?
Yeah, that's right. So now we are trusting also requests coming from other domains. This is what we have to add in Istio configuration. Yeah. So once we have that, also this is done by Spire. Now we trust both domains and we trust both bundles. So we trust the certificate, the bundle from domain cluster 1 and the bundle from domain cluster 2. So this is Envoy configuration. So this was like the theory, and I'm going through the demo. This is the GitHub repo that we use for this. Here you have everything, and everyone can use it and can perfectly reproduce this environment. We have it public, and it's very easy to use with a makefile. It should be very easy to deploy everything. So going through the lab, we have two contexts. One is can install cluster 1. So if we check here the pod, we see that we have in book info product page, we have the East Ingress Gateway, we have the Istio control plane, we have some observability components, Kali, Prometheus, Thanos, and here we have in Spire system, the Spire agent and the Spire server. If we check which pods we have in cluster 2, we have the backend applications, details, ratings, reviews, Prometheus also, and we have exactly the same in Spire, so Spire agent and Spire server. So they are federating one between each other. So in order to make this setup even more secure, we have added also some security policies in our East Ingress Gateway. For example, we have added an authorization policy and request authentication, which basically is checking that the JOT that the user provides is verified by the certificate that is specified in this URL. So we have basically this certificate and this JOT, not this one. Yeah, and basically what we are doing is trusting that the JOT provided by the user has the same issuer and the same subject that we specify here. So let's try to make one curl with the token that we have in this URL. And we see that we are able to access the application. And if the user specifies affect token, we get this error. That issuer is not configured, just for adding more security to our demo and make it like more interesting in security purposes. So I'm going to leave a for loop running here. So this is going to make a request every time to my application. And we also wanted to show the capabilities of the SPIFFE IDs. So we are able also to play with authorization policies. For example, in this case, we are applying an authorization policy in the remote cluster, in cluster 2, saying that only we allow requests coming from this SPIFFE ID, which is the domain from cluster 1, namespace book info, and service account book info product page. If we try to make a request from a SPIFFE that is different to this one to review's application with this path and with this method, we will get the request denied. So let's give it a try. We are going to make the request from the sleep pod, which is not this SPIFFE ID, and we see that we get airbag access denied. So this was just for demonstrating also the purposes of having SPIFFE IDs and how to play with them for security purposes. And from the calls we are making, we are able to see also, we get into the book, we are able to see what is forwarded from cluster 1 to cluster 2 when we establish communication between one workload and the other. So in this case, we are able to see here the SPIFFE ID of the backend application, which is reviews in this case. As you can see, domain of cluster 2, namespace, and service account, the hash, the subject of the certificate, and the SPIFFE ID of the application that is doing the request. So we are able to see all this information if we enable the book logs in our cluster.
So in the authorization policy, can you just go back just a little bit? So when you said the allow from that specific principle, so if I would make a call from cluster 2, it wouldn't work, right?
Yeah, it wouldn't work.
It has to be specifically cluster 1, right? In
Yeah,
this
that's
case,
it.
right? Okay.
That's it. It has to be specifically the domain that we are indicating into the SPIFFE. So the SPIFFE must be exactly the same one than the one that we specify here.
Mhm.
And yeah, just for some observability, we have here Kiali, which is basically getting metrics from both clusters. And as we are able to see here, if we display also the security and the traffic animation, we are able to see that all the requests are coming to our East Ingress gateway, reaching our front end, and being able to reach also the remote cluster. We are also to see here, we are able to see here some interesting things as mTLS enabled, and we are also able to see the principals, the SPIFFE that are making the request and the one that are receiving the request. In this case, we have that product page book info is making the request. And here we have that the response, well, the request is coming to book info reviews in the remote cluster. And if we check what packets are we receiving, I have here a Wireshark that was running before, and we have here the application data that was sent. So basically, this is the IP from the node 1, and this is the IP from one workload in the remote cluster. And if we check the transport layer security, we are able to see that we have the encrypted application data. And if you check on the right, all the data of the application that is reaching is everything encrypted. So this is a very secure setup working with mTLS, Istio, and SPIRE. So yeah, this was a bit of everything of the demo of our setup.
Yeah, this is awesome. Can you go back to Kiali? I always like watching the
Yeah, sure.
this overview of like basically seeing everything, even across clusters, right? How where stuff flows, the fact that there is mutual TLS, right,
Yeah,
between all of them, right, and not only that, it's using the identities, right, that were issued by two separate Spire servers or Spire agents in this case.
yeah, that's right. Also, if we execute this call, we will be able to see. I will execute some calls. We will be able to see also in Kiali how does this request gets rejected if we don't make the request from the appropriate workload. So, thanks to the authorization policy, is detecting that the request was not done with the correct SPIFFE ID, and the request has been rejected from this workload but accepted from this one.
Yeah. So basically, I mean, the thing is, once you have these strong identities, right? Once these SVIDs, right, X509 certificates are issued, you can do all these like authorization policies on top of it based on that. And regardless if it's on one cluster or if you have multi-clusters, right, or if you have Spire, or if you don't have Spire, or if you have multiple Spires, or if you have one Spire, right, it doesn't really matter in the end, right?
Yeah, that's right. We could also have this setup with an external VM. Doesn't have to be Kubernetes cluster. We could also use Spire in order to connect to external VMs securely.
True. Yeah. You're right. Yeah. You could have like multi-clusters with like VMs as well, and connecting those to the mesh and giving those like SPIFFE identities, right, or SPIFFE IDs. And then also, I don't think you mentioned, but the Spire agents, right, can also be configured with like CAs that are like external. Like it doesn't have to be a self-signed certificate or self-signed CA, right? It could be something that's running. I think AWS has like a certificate manager, I think, or something like that, and then GCP has an equivalent of that as well. So you could have those services then issue or create the intermediate certs, right, and then those are then used to create the workload. It's like it's like everything connects to everything in a way, right?
Yeah, that's right. Yeah, and there are some use cases of organizations that have this exactly for that, because they want to have a unified root CA for everything, for the clusters, for the VMs, for everything, and then they can generate intermediate CAs in each
Yeah.
deployment that they have. Yeah.
Yeah. And even if they don't, right, then they can do the federation if they want to, right? If they want to connect, right, or have the workloads in another trust domain, right? They could do it with federation like this, right?
Yes, and they can also have a central Spire server that delegates to others. So there are many complex configurations that you can have.
So you could have like a one central Spire server to rule them all, and then that
Yes,
Spire server issues like identities to other Spire servers, and
correct.
oh,
So how complex you think it can be, it is. So yes,
oh yeah. So you can solve a lot of different issues, right? I mean, not issues, scenarios, I guess, not issues, right? Or
yeah,
that.
different customer or use cases are supported. Yes.
Mm. Awesome. Well, if anyone has questions on the stream, I know LinkedIn is a little bit behind on the stream. They always have like a couple of minutes of delay. But in any case, if there's any questions, feel free to ask. Edu, I didn't ask you, how was your KubeCon experience? Did you like it?
Yeah, it was great. Really. I think it was more than 10,000 people there in KubeCon this year. Yeah, you had the chance of making networking with a lot of people, talk about technology. Yeah, you are surrounded by computer science people also. So that experiences are always great. Yeah.
Yeah, I agree. It was great. It was very busy. A lot of people, a lot of old faces, old people that we've met before, and a lot of new people, right? So
Yeah, that's
yeah, and I think they already posted all the videos as well
They
on
were
their
really fast because it was like, I don't know, 2 days after the KubeCon, all the YouTube videos were uploaded. So yeah,
Yes, yeah. I was surprised because it typically takes them longer than that, but that was great. Alberto is asking for repo. Yes, let me share GitHub repo demo. I realize that the comments that I make here don't necessarily get posted to LinkedIn, so
oh,
I
oh,
posted it there. But yeah, there's a repo there. So all right. Well, I'm not going to keep you any longer. Thanks for taking the time. And for any questions, if people have any questions or comments or whatnot, feel free to like comment on LinkedIn, uh, contact either one of us, right? We'll be able to help you with your questions. And yeah, thanks again, guys. And I'll see everyone in a couple of weeks, I guess, on another stream. Thank you.
thank you everyone. Have a good day. Bye bye.
Bye.
ciao.